Right class, now we are going to chapter 9, correlation and simple linear regression. Okay, actually I'm using these notes from the past sem, that is why it is chapter 8. Okay, for your syllabus it is chapter 9, but don't worry, we are still using in the same notes. Okay, so in this chapter, saya hanya explain. Okay, you guys just listen carefully and refer on your notes. Okay. So correlation and simple linear regression. Okay, it means this chapter we want to determine the relationship between two variables. Okay, we want to determine the relationship between two variables. Okay, before that we need to identify what is variable, which one is variables. So look at examples. Okay, examples 1. Okay, a doctor needs to find out how strong is the relationship between the level of fats and blood pressure in a patient before he can help him. So there are two variables in there. Which one is variables? Okay, as you can see, the level of fats is the first variable and the blood pressure is second variables. Okay, that is the two variables in this statement. For example 1. Okay, example 2. An educator might be interested to determine whether the number of hours a student studies is related to the student's score on a particular exam. So, which one is variables? Okay, as you can see, the number of hours student studies is the first variable and student score is the second variables. Okay, boleh faham dah macam mana kita nak find out which one is variable. Okay. And then next, the kind of relationship that exists between two variables and its strength can be measured using correlation analysis and regression analysis. Okay, so the two variables, okay, we can identify the relationship by using correlation analysis and regression analysis. What is correlation? It helps to determine the strength of relationship between two variables. Okay, correlation ni, that means we can measure how strong the relationship between two variables. Okay, for regression analysis, it helps to determine the types of relationship that exist between two variables. Can also predict a dependent variables if an independent variable is given. That means regression analysis, we can determine the type of relationship, whether it is strong relationship or moderate relationship or weak relationship. Okay, there is function for regression analysis. Okay, so the first one we focus on correlation. Okay, correlation is a statistical method used to determine whether a relationship between variable exists. Okay, it is measured. It can be used to measure the strength of relationship between two variables in a sample is called the correlation coefficient. Okay, before we want to measure the strength of the relationship between two variables, we need to identify which one is dependent variable and which one is independent variables. Okay, what is dependent variables? Dependent variables, look at your notes. It is the variable that is being predicted or estimated. So dependent variables, okay, we let as y. Okay, we let as y. For independent variables, what it is mean by independent variables? It is a variable that provides the basis for estimation. It is predictor variable. Okay, independent variable, we let as x. Okay, we let as x. That means these two variables, dependent and independent variables, y will be depends on x. Okay, for example, okay, look at example kat bawah tu. The grade a student earns in an examination depends on the number of hours he or she spends studying. So which one is variables? The grade students and the number of hours, right? The grade students and the number of hours. Okay, so which one is dependent variable, which one is independent variable? Okay, and of course grade student is dependent variables. Okay, dependent variables, and number of hours student study, it is independent variables. Okay, dependent variables we let as y, independent variable we let as x. Y, it is depends on x. Okay, y, it is depend on x. That means the number of hours student study ni, okay, semakin banyak masa awak study, okay, you will get the good results. Okay, the more the number of hours you study, the more the grade student you can earn. Okay, you will get the good result. Okay, do you faham now? Independent variables and dependent variables. Okay, alright, look at the next page. Scatter diagram. Okay, a useful first step in looking at the relationship between two variables is to portray the information in a scatter diagram. Okay, it helps to describe the nature of relationship between independent and dependent variables. Okay, that means we can find out the relationship between two variables by using scatter diagram. Okay, there are three types here. Positive correlation, the first one. Positive correlation. Okay, positive correlation, it is describe a positive relationship between two variables x and y. Okay, the graph. Okay, if x increase, y also increase. Okay, this is x, this is y. If x increase, y also increase here. Okay, dia akan increase, dia menaik ke kanan. Okay, so this is we call as positive relationship. Okay, negative relationship, it is described as negative correlation. It is described as negative relationship between two variables. Let's say we have x here, y here, and then the graph would be like this. It is decrease. If x increase, x meningkat, okay, but y, it tends to decrease. Dia menurun macam ni. Okay, y, it tends to decrease. Okay, daripada duduk atas, dia menurun ke bawah. Okay, so this is negative correlation. Okay, and the last one is no correlation. No correlation, it is described there is no relationship between two variables x and y. Okay, it means the graph would be like this. Okay, or it will be like this also. Dia berselerak. Okay, or it will be like this also. Okay, dia mendatar saja. Okay, there is this is no correlation. Okay, ni faham now? Okay, this is for scatter diagram. Okay, next page. Okay, look at example 1. Table 1 gives the number of sales calls and the number of units sold in a month of MRM system. Okay, so based on the data, based on the data yang dibagi dalam notes tu, we can draw a scatter diagram. Okay, for example, we have sales calls here. Sales calls. And then we have units sold. Okay. And then we know that sales calls is X. X, what is mean by X? It is independent variables. Okay. Unit sold, it is Y, dependent variable. Okay, and then we have a data here, 14 for example, 28. Okay, and then awak tahu kan macam mana nak lukis scatter diagram? Dia macam ni for example, we have here 5, 10, 15, 20. This is for X. And for Y, boleh nampak lah. Okay, for Y, we have 10, 20, 30. For example, okay, when X is 14, Y is 28. X 14 kat mana? Kat sini. Agak-agak je. Okay, yang ni saya tunjuk contoh. X 14 kat sini. And then Y is 28. 14, 28. This one. Dia agak-agak kat sini. Okay. So, yang garis-garis ni tak payahlah buat. Okay. That means awak mark saja. Okay. When X is 14, Y is 28. Mark kat sini. For example, when X is 6, Y is 22. For example. Okay. So, 6 kat mana? 6 kat sini. For X. Okay. For Y is 22. Awak mark dekat sini. Atas sikit daripada 20. Okay. So, this is how to draw the scatter diagram. Okay. Awak boleh proceed lah untuk lukis yang data-data lain. Okay. Yang ni saya tunjuk ringkas saja. Contoh ringkas saja. Okay. For scatter diagram. And then kalau awak tengok pada notes tu. Okay. For scatter diagram. Awak tengok. Ni contoh So, it shows you it is positive correlation. Okay, dia meningkat. When X increase, Y also increase. Okay, it is positive relationship between the sales calls and unit sold. Okay, boleh faham now? And then, next, correlation coefficient. Alright, correlation coefficient, it is, we use a symbol R. Okay, correlation coefficient, we use a symbol R. Okay, so look at your notes. The sample correlation coefficient would take on values ranging from -1 to +1. Okay, that means, okay, value for R is between -1 to +1 only. Okay, and then we have a 0 value here. Okay, and then a value of -1 would mean perfect negative correlation. So for value -1, it is negative perfect correlation. Yang ni saya short form kan negative correlation. Okay, no, negative correlation here. Okay, while +1, it is perfect positive relation. Okay, perfect positive correlation. Okay, and a value of 0 would indicate the existence of no relationship between the variables. There is no correlation, no correlation here. Okay, and then figure 5, the relationship between different types of correlation and the value. Okay, so now we need to find out. Okay, we need to measure the correlation coefficient. Okay, with symbol R there. Let's say we calculate for value R. If we get the value R is in between 0.1, 0.2, 0.3. Okay, yang ni saya just nak explain dulu. Okay, when you get the value R is 0.1, 0.2, 0.3, it is called weak, whether it is positive or negative relationship. Okay, it is called weak relationship. Okay, apa yang positif negatif ni? That means when you get the value for R is 0.1234 actually. For example lah, 0.1234. Okay, 0.1. It is weak positive relationship. Okay, when you get the value for R, it is negative 0.2341, for example. So you can describe as weak negative relationship. Okay, you faham nah maksud saya ni? Okay, it is between 0.1, 0.2, 0.3. How about when you get the value for R 0.4, 0.5, 0.6? Okay, it is we can describe is moderate relationship. Okay, moderate relationship. Okay, when you get the positive 0.5, okay, you get the value 0.56 for example. Okay, it is moderate positive relationship. Okay, and what about when you get the value R is in between 0.7, 0.8, 0.9? It is strong relationship. Okay, it is strong relationship. Okay, so for example, I give you a value R equals to 0.3. Okay, it is weak positive relationship. When R it is equal negative 0.7, so how to describe this relationship? Okay, it is strong negative relationship. Strong negative relationship because it has negative here. Okay, what if when you get the value of R is 0.9? It is strong positive relationship. Okay, you faham nah? Okay, so now, so to measure the correlation coefficient, okay, kita nak dapatkan value for R ni. Okay, correlation coefficient is by using the person's product moment correlation coefficient. Okay, we call as person's product moment correlation coefficient. Okay, it is only measure the strength of a linear relationship between two variables. Okay, so okay, so this is formula that we need to use. Okay, we need to use to calculate the correlation coefficient. Okay, RXY tu, the symbol RXY tu, that means the correlation coefficient between these two variables X and Y. Okay, by using the formula apa? Total XY. Okay, boleh nampak lah, total XY minus total X times total Y divided by N. What is N? N is sample size. Divide the square root of total X square minus total X power 2 divided by N times with total Y square minus total Y power 2 divided by N. This is the formula that you need to use to calculate the correlation coefficient. Okay, we call this the person's product moment correlation coefficient. Okay, so awak tengok pada kat sini lah, total X apa? Sum of the X values. Total Y is sum of the Y values. Total XY is sum of the product of X and Y. Total X square is sum of the square values of X. Total Y square is sum of the square values of Y. N is the number of observation, which is sample size there. And then R is the coefficient of correlation. Okay, so look at example 2. Okay, look at example 2. So, okay, example 2, okay, it is from example 1, okay, sales calls and unit sold. Okay, sales call and unit sold. We know that sales call is X, unit sold is Y. Okay, then you need to calculate the XY. Okay, you need to calculate the XY. You need to calculate XY, X square, and Y square. Okay, so bila awak calculate ni, for example X is 14, Y is 28. For XY, 14 times 28, you get 392. For X square, 14 square, you get 196. For Y square, 28 square, you get 784. Okay, and then adalah data-data kat bawah tu, you can proceed. And then what? You need to total up. Total up for X, you get 199. Total up for Y, boleh nampak dah. Total up for Y, it is 408. Total up for XY, you get 9661. Total up for X square, you get 4681. For Y square, you get 20510. Okay, 20510. Okay, after you have done calculate this, okay, this term xy, x square, y square, then you need to substitute into formula for correlation coefficient. Okay, yang tadi tu, yang saya dah tulis formula tadi tu, substitute into that formula. Okay, you will get the answer is 0.9238. Okay, awak calculate, awak akan dapat 0.9238. Then you need to interpret. Okay, interpret dia. You know that 0.9, okay, positive 0.9, it is strong relationship. Okay, it is a strong positive relationship. Okay, awak kena mention lah, interpret kan. Okay, okay, kalau tengok pada solution kat bawah ni, the value obtained is 0.9238. We can conclude that there is a strong positive relationship between the number of sales calls and the number of units sold. Okay, anda faham tak? Okay, konsep dia to find the correlation coefficient. Okay, next, simple linear regression. Okay, simple linear regression. In regression analysis, we develop an equation. Okay, we develop an equation to express the relationship between two variables and estimate the value of the dependent variable y based on a selected value of the independent variable x. That means for simple linear regression, we need to make an equation. Okay, how to make an equation? By using the least square method. The general form is y equals to a plus bx. Okay, we need to make an equation. Okay, by using the least square method. Okay, we know that y, okay, look at your next slide. Y is the predicted value of y, x is the value of x, a is the y-intercept for the sample, b is the slope for the sample. Okay, so this equation requires the determination of two regression coefficients to predict the values of y. Okay, to predict the values of y, which is a and b. So a and b ni adalah two regression coefficient here. Then we need to find the value for a and b by using formula. We know that the value, to get the value b, sample size. Okay, awak tengok pada notes. Okay, tengok pada notes. The sample size times with total xy minus total x times total y divided by the sample size times with total x square minus total x power 2. Okay, and then for formula to get the value a, total y divided by n minus b times total x divided by n. So, to make an equation, you need to find the value for b first. Why? Kenapa cari value for b, bukan a? Because to get the value for a, we have a value for b. Okay, so the first step, you need to find the value for b first. Okay, supaya bila awak dah dapat jawapan value b, then you can substitute into formula to get the value for a. Okay, boleh faham dah? Okay, so look at next page. Okay, so kita dah ada dah total up dia. Okay, total x, total y, xy, x square, y square. Then when you need to find the value for b, just only substitute into the formula. Okay, for example, you get the value for B is 2.1387. Okay, this is value for B. And then, to get the value for A, substitute value for B here. For example, kita substitute 2.1387 times with total X divided by N. Okay. Dia faham tak? Since this is positive. Okay. Negative ni sebab apa? Sebab formula dia. Memang ada formula dia. Okay. What if you get the negative value for B? So, it will become positive. Here. Okay. Negative, negative, positive. But now, it is positive value for B. So, it will become this negative lah. Follow the formula. Okay. And then, you will get the answer is negative 1.7601. Okay. So, after you have done calculate for value A and B, then you can substitute into an equation. Y equals to, since A we get negative 1.7601. And then plus, okay, plus Bx. B is 2.1387x. So, this is equation. Okay, this is equation. Okay, between the two variables. Two variables, that means sales cost and unit sold here. Okay, you faham now? And then, look at the last topic, estimating the dependent variable using the regression equation. Okay, using the regression equation. That means, kalau tengok pada last topic tu kat bawah tu, using the same data in example 1, what would be estimated the number of units sold if 20 calls of sale in a month have been made? Okay, that means we want to estimate the number of units sold. What is the number of units sold, which is Y? Kita nak estimate Y, but dibagi kat situ apa? 20 calls of sale have been made. 20 calls of sale, that means it is value X. So, when X equals to 20. So, 20 ni substitute into this equation. Okay. When X equals to 20. Okay, 20 calls have been made. So, 20 ni kita substitute into this equation. Why? Because we need to estimate the value for Y. What is the number of units sold? So, Y, it is equal negative 1.7601 plus 2.1387 times with 20. Then, you will get the answer is 41.0139. So, this is the answer. Okay. So, the estimated number of units sold is 41.0139. Okay, take 4 decimal places. It's okay. Take 4 decimal places. Okay. Yang tadi value for R tu also 4 dp. Okay, value for R, correlation coefficient, also 4 dp juga. Okay. Alright. Boleh faham now? And then, make sure, okay, ni saya nak tekankan kat sini. Make sure, okay, sometimes dia bagi statements, dia tak letkan X and Y. Dia tak letkan X and Y. So, you have to determine which one is independent, which one is dependent variables. Okay. So, if awak terbalik if awak letkan terbalik, that means sales cost ni awak letkan sebagai independent variable, unit sold ni awak letkan sebagai dependent variable. So, calculation dia, calculation for correlation coefficient awak betul. But, for equation, awak akan salah. Okay, for value B, yang tadi awak dah calculate for value B, value A. Okay, awak dah calculate. Okay, this one awak akan salah. And then, equation pun awak akan salah. Estimated pun awak akan salah. Why? Because awak dah letkan daripada awal ni, dependent and independent variables ni awak dah terbalik dah. Okay, awak dah salah let dah kat situ. Okay, for correlation betul, for R ni betul. Okay, yang ni tak ada masalah yang ni. Tapi untuk value B, value A, equation and estimated ni awak akan salah. So, be careful. Okay, be careful when you want to state the independent variables and dependent variables. Okay, you faham now?